From analog.
Hi, Jim. You have a great signal up here. You're 5.9 plus.
To digital.
We are everywhere you want to be. This is the CQ Blind Hams Podcast.
Hello, everybody, and welcome to the CQ Blind Hams Tech Zoom, where we get together in person, but virtually, to discuss all kinds of ham radio related topics. If you want to find out more about the Blind Hams Network, of course, you can go to www.blindhams.com, find out all about our bridge, all about our podcasts, all about our wonderful ham related resources. That page is just full of lots of good stuff. And of course, it's got a very convenient link to this conference, which again meets every second Thursday of the month. So let's see. We're going to go ahead and start by introducing everybody here. We're missing a few. So let's go to Robert, NC5R. What's going on with you?
Well, thank you, Julian, and good evening, everybody. I am Robert. Nice to be here again for a Tech Zoom. We are missing a few people, unfortunately, who either aren't feeling well or maybe have other things going on, but I'm glad to be here and looking forward to having a good discussion about how to protect our equipment from lightning. Back to you, Julian.
Thanks, Robert. Yeah, I think it's going to be a very fun discussion. I love thunderstorms and all that good stuff, but yeah, they can not be so friendly to our ham gear. So looking forward to learning about ways to mitigate their potential damage. And Steve, WB2KTV, how are things in New York?
Evening, Julian. Doing well. Lightning is of particular interest to me, being an apartment dweller. When you're in a big apartment building, sometimes you get the feeling that you're safe from such things. But I suspect over the next 45 minutes or so, I'm going to find out that that is not true. And if I find that out, I feel I'm in the right place to learn how to mitigate it, as you said.
Yep, absolutely. And I can tell you, not necessarily firsthand experience by me, but by my parents when they were living there in New York. During one particular thunderstorm, some bolt must have hit pretty nearby, and it fried a TV. So it can happen even if you're in an apartment building. And it should be interesting because this weekend here in Southern California, we are actually expecting to have a close brush with a tropical system, which is not very common here, but there is one off the coast of Baja, down there in Mexico, and we are actually supposed to feel some effects from that, which we're actually looking forward to because it means beneficial rains and hopefully breaking this long heat wave that we've been stuck in. But there is that thunderstorm potential. So absolutely, it doesn't matter where you are. They say when thunder roars, head indoors, but even indoors, there could be some tricks and things you got to look out for. Angelo, I think, is in a meeting, so we won't call on him, but he is monitoring things with one ear and making sure that it's all running the way it's supposed to. And of course, last but not least, myself. My name is Julian. My call is N1CA. I'm in Los Angeles, California. So tonight we're going to be talking about lightning. It's all about what we can do to protect ourselves, protect our shack and our equipment from the adverse effects of it. It's one of those things that we have no control over. The bolt comes out of the sky and who knows where it's going to land and what it's going to do. So without further ado, I'm going to kick it over to Robert because I think he's got a video that he's going to queue up for us that will get this discussion started.
Yeah, thanks, Julian. I'm going to play an audio clip from a video from a YouTube recorded by a NASA scientist by the name of Monty Bateman. He is a lightning expert, and he's talking all about some different issues regarding lightning and how to protect yourself as best you can from it. So let me start my screen share and see if we can roll this video here.
You have started screen share.
I'm Monty Bateman. I'm a lightning scientist with NASA, and I want to tell you how to help protect your shack from lightning.
Just let me make sure, Julian, can you hear that okay?
Yep, well, it came through just fine.
All right, here we go.
Remember, rule number 1, lightning cannot be prevented or eliminated. So my typical disclaimer is, lightning is unpredictable, there is no guarantee, use this at your own risk, and even if you follow our advice, we cannot be held responsible. Okay, so how do I figure out what needs protecting? This is actually a picture out of an old ARRL handbook. You draw a picture of your shack and everything in it. Then you draw all of the connection lines to the outside world. Power, phone, coax, Ethernet, anything that brings something in or out of your shack. Then you draw a red line around it, and whatever crosses that red line probably needs some kind of protection. Okay, so people want to know about, does lightning go up or down?
Oh, yeah.
And the answer is yes. So when there becomes an abundance of charge in a storm or in a cloud above you, air breakdown begins. And that creates what we call a stepped leader. And the stepped leader moves in jumps of about 50 meters. And it jumps 50 meters and pauses, another 50 meters and pauses, until it moves its way down toward the ground. So when it gets close to the ground, anything that's near the end of that leader will shoot up a streamer. So here I've drawn a house and a tower. So both of these launched up a streamer, but it only connects with one. And so here in white, which is really hard to see, is what we call the return stroke. So that means this leader has made a connection with ground, and then we get infinite current up. The leaders are very low current, so that means they're very low in light. You can't see them very well. You got to have low light cameras to see leaders. And that's because a cloud is an insulator. It's not an infinite source of charge. It only can dump out tens of amps. But the ground is an infinite supply of charge, so we can get 100 kiloamps off the ground, back up that hot channel.
Move over here for me so I can get.
All right, so there are 4 kinds of hazards that we need to worry about as ham operators. Number 1 is static charging. Let's say you have a dipole out and the wind is blowing and you might get static charge on your dipole. So here's my suggestion for that. This is an old-fashioned coax switch made by Heathkit or others. And here's a ground lug. So you switch it to ground and it grounds all your lightning, your antennas, to discharge any sort of static charging. Static charging is not dangerous to people, but it could zap a receiver. So do not confuse this with lightning protection.
Okay.
All right, so now we go back to number 2, nearby lightning. So up here in the process, let's say this house launched a streamer. It wasn't part of the lightning flash, but that streamer could be tens of amps of current, which could still blast a ham radio. So this is what we're talking about for that process.
Okay.
So number 1 is what I call what trade name is a transorb. It's like 2 Zener diodes that are built nose to nose, so it can conduct in either direction. These are great for transit protection because they react very quickly, but they don't handle a lot of current. So what we recommend is that you couple a transorb with an MOV. MOV can handle a lot of current, but it takes them a long time to turn on. So you put these 2 together. This is not good for RF because it's got an enormous amount of capacitance in it and it causes a phase shift. But for RF, there's things like spark gap, and I just have a picture of an MFJ one because I like about this one, it has a replaceable spark gap tube. So once it's popped, you can change it without replacing the whole thing. Okay, so that's nearby lightning. Okay, near miss, let me back up, I said that wrong. Nearby lightning is, say lightning hits out on the other side of your yard and it's going to induce voltage into anything that's connected to your shack. Any wires act like antennas for the lightning energy.
Okay.
Then the near miss is the unsuccessful leader from that picture. And so this is a series of photos taken by a guy named Bill Otten, KC9CS, and he graciously put these on a website, which I borrowed. So you see here, this is the top of a tower. It's a tower that's laid over, and what we're looking at is the thrust bearing for the rotor. So he's put coax feed-throughs at the top of his tower. So that means all the shields from that coax are bonded to the top of that tower. And at the bottom of the tower, he's got a plate, and the coax shields are all bonded together again at the bottom. So at the top and at the bottom, we've got them all bonded together, and then you see copper ground lead coming away from the tower. Now at the point of entry, here's a large copper plate, and again, all the shields are tied together, and there's a piece of copper that goes to the ground and comes back over here to connect with the tower. Now on the inside, on the back side of the wall, or the inside of the wall, here's a plate on the inside of his shack, and so every ground from everything and all of the coaxes are bonded together at this plate, and then there's flashing that goes back outside and ties back to this one. Perfect insulation. This guy did it right. So everything is bonded, everything is grounded, and the key is to tie all the ground points together at the point of entry to the building. All right? So I always tell people, look at what the pros do. This is a commercial radio station. This is a picture from the Polyphaser catalog. Not an advertisement for them, but it's a great picture. So here's a plate that has a bunch of hardline entry points, and then 4 wide, flat copper straps that go into the ground. Exactly what we're talking about. Bond all the shields together at the point of entry to the building, and then tie that to ground. And then ground everything inside to that as well. Alright, so this is another picture. I like to show this picture. It was taken here in Alabama. You notice what it looks like when a tree gets struck by lightning. It lights up the whole trunk. But what's really interesting about this picture is right here next to the lightning flash is a leader that was not part of the lightning flash. That's a leader that was launched, and it's hard to see in the paper, but there's a parking lot light right here. It's also got a streamer onto it. So we got 3 streamers, and the lightning chooses 1. Okay? So for direct strikes, that's the worst case scenario. You want to convince the lightning current to take a path through the tower, because the tower can handle that current. 100 kiloamps is not uncommon for a lightning flash. So this is the same picture you've seen before. We're bonding the coax shields to the top of the tower. We want to make sure that the direct strike current goes through the tower and into the ground. Okay, and then people often ask me, what makes a good lightning rod? And one of my colleagues, Charlie Moore, made these lightning rods. These are homemade, 1/2 inch, 3/4 inch, and 1 inch aluminum rods. He took to the machine shop and just had them rounded over into nice smooth ends. Did a competition. I used to work in New Mexico at a thunderstorm laboratory in the mountains. And so he peppered the side of the hill with homemade rods and interspersed commercial rods. Not one of the commercial rods took a strike that summer, and all of the strikes hit the homemade rods.
Oh, wow.
So I don't have time to go into the physics, but it has to do with corona emissions, and basically sharp rods shield themselves and not much else.
Okay.
And so the blunt rods are unshielded, and that's what you want. Okay? And again, part of a direct strike is if you have a rotor, you're not going to be able to bond the antenna mast with the tower because of the rotor, and so you can insert a loop of say number 6 wire from above to below the rotor. Again, trying to couple the energy from the antenna into the tower.
All right. So that's some pretty good information. I thought I will stop the screen share and turn it back to you, Julian.
Alrighty, yeah, that was very interesting. I was sort of in my mind visualizing things. He did a good job describing things. So, yeah, and he's in a good place for it, Alabama. They certainly get put to the test there. So, anybody want to add to this discussion about lightning? Maybe what you're doing in your shack to try to minimize the effects?
I'd like to know what he meant by sharp rods versus, did he say dull rods? Does it mean rods that come to a point versus rods that come to a flat end? Is it that simple? Anybody know?
Yeah. I know I don't.
Well, the only thing that I could offer is that I can remember in my younger days going to the state fair, and they always had somebody or several booths there for lightning rod protectors for farms, for barns and the farmhouses. And those lightning rods always came to a sharp point. And I thought he said that the commercial rods took the hits because they had the sharp points. And I may have that backwards, but
yeah, you do have it backwards. He was saying that the rods that were not pointed, the homemade ones took all the hits, and the commercial rods didn't get a single hit throughout the summer.
Okay. Yeah. Yeah. All right. Well, for what it's worth, Steve, that's all I can tell you about. I just remember seeing all of the lightning rods that, you could put at the top of your house or your barn, came to a sharp point. So I guess that follows with what he was saying, is that the lightning goes someplace else.
He's not big on commercial rods, I don't think.
Yeah, I don't know what his point was, though. I mean,
I guess the point is you want the lightning rod to be the thing that takes the hit, as opposed to some other part of your station.
All right.
Yeah, I guess that makes sense to me as well. That, the whole idea is that if anything's going to get struck, you want it to be the rod, not something of value that could be damaged or could cause damage.
One thing that was interesting to me, is that he makes no bones about the fact that you cannot do a whole lot if you get a direct hit.
Right.
Yeah.
I think that's pretty much an assumed, yeah.
I did see some other videos when we were preparing for this, and one guy made a really interesting case, and he's another lightning expert from somewhere. He said that there are a lot of myths on ham radio, and one of the most egregious myths that he really didn't like at all is the myth that you can stick your coax in a cookie jar and protect yourself somehow from lightning getting out into your shack if you get a strike. He said there's absolutely no truth to that.
Yeah, I have heard that also.
That sounds kind of crazy.
Yeah, bell jar. I guess they figured because the glass jar might be an insulator from anything else that's around, but
that's what they always say, that it's an insulator. But this guy says no, that there's nothing to that. But anyway, part of my point, honestly, is there are a lot of different opinions, a lot of different thoughts, and a lot of disagreement on what to do about lightning. But there's one thing that anybody can agree on: it's dangerous, and it's potentially very harmful to our equipment.
Yeah, that's for sure. I mean, I from an apartment dweller's point of view, generally when there's a high likelihood of that kind of weather, and here in Southern California, we don't have a lot of it, but when there's a high likelihood of it, especially if I'm not going to be here, I will go ahead and, unplug stuff, just unplug stuff from the wall altogether. And, disconnect. I don't have anything outdoors right now, so as far as antennas go, so I don't have to worry too much about that. But yeah, for sure, anything that's plugged in that's sensitive, radios, computers, what have you, I'll just go ahead and unplug all that stuff.
Yeah, I mean, you're making a great point that I suppose a lot of us who are not apartment dwellers haven't thought much about. But it's not just those of us who have antennas outside or towers up and all that, but everyone has to be at least somewhat concerned about, lightning coming in and damaging all that equipment that you just mentioned. I mean, it's something worth thinking about.
Not to mention your house.
Yeah.
Yeah, I mean, that's worst case scenario. And I've heard a few stories so far this month from out of Florida about houses that have been struck like that, and it just takes the roof out, and sometimes even causes a fire, and there's a lot of damage that ensues.
Unfortunately, he's not here to tell us about it, but I know Joel had a really bad experience with lightning hitting his equipment in Tennessee, and I've know a guy here who had a lightning strike come through his house, through his ham radio equipment, and started a fire. So it is something to be concerned about.
Right.
Yeah,
And again,
for sure.
It doesn't take a direct hit. The nearby strike was what got Joel's equipment. And so, as the NASA expert said, all of your, everything you've got connected is like an antenna that's going to pick up the, whatever energy is emitted by even a nearby strike. So, it's something to be mindful of.
You don't know where it's going to go, and that's the risk. I think sometimes I've even been a little bit too blasé about it, and I'm like, well, that thunder sounds kind of distant, probably don't need to worry about it too much. And maybe that's okay, but maybe not, because you can't tell exactly what the lightning is going to find to be attracted to. And so it's especially problematic here, and maybe it is, where you are also, Russ, that we get a lot of thunderstorms, and I'm always unplugging stuff.
Yeah, I mean, we do too, and I have to admit that I'm a little lazy on that point. I think one thing, I mean, this comes at a good time because I'm kind of rearranging my bench, and at a club breakfast a couple of days ago, we were talking about grounding, and I said, well, I've got a 10 gauge, it's a stranded wire coming from my water pipe, but everything is daisy chained. And one of the guys, electrical engineer, says, oh, no, you got to tie that to a bus and parallel all the connections to your various pieces of equipment rather than daisy chaining it. And I said, well, how about the water pipe? It's a metal water pipe that's a couple of feet from my bench, and it runs directly outside underground. That's fine. He said, that's a good ground. But he said, get a bus, get maybe 8 gauge wire, solid wire, run it from the water pipe over to the bus, and then make parallel connections to all of your equipment. Okay, so that worked in fine since I said I'm rearranging my bench top. So that's a good opportunity to get all that cleaned up.
Yeah, and if I'm not mistaken, Robert, you can correct me if I'm wrong, but with the thing that happened to Joel, wasn't it that he forgot to unplug a USB cable out of a radio or something like that?
Yeah, that's the sad part. He had unplugged everything except that one cable, and that got him.
Yes. Yeah, thankfully I haven't had anything even close to that. But as I mentioned in the beginning, my parents had a thing that when they were living in New York, in Manhattan, in an apartment, and they had a pretty good storm that came through, and a lightning strike, I guess, must have happened nearby, and it took out their TV. And they were connected to cable.
Yeah, I mean, I've been fortunate to not have anything like that either, and I hope I never do, but you never know. But I feel particularly vulnerable because I have a 40-foot tower up in my backyard. I do have a lightning rod and have it grounded, but you know, you never know what's going to happen. And this certainly has made me pause and think about maybe even more things that I could do.
Yeah.
Any other comments from anybody else about this particular video or about this information?
Well, the thing that I found interesting was how the bolt of lightning comes down in steps, and then there's the leader comes up from the ground, and when he said, which way does lightning travel, up or down? Yes. Well, that's kind of goes in both directions, but lightning is fickle. It just, there's no rhyme or reason to it. And like you said, taking out the television sets, Steve, sometimes it seems like it's just random. You'd think it'd take out everything, but you know, why the television? Who knows? And it's just.
Yeah, I got a couple of things to add.
Go ahead.
Go ahead, Angelo.
Okay, so he talks about ground rods. If you actually, a lot of these commercial ones do have pointed rods, but if you sledgehammer, you can actually round them off. And one of the things that he kind of took lightly was on the aluminum, the relationship between the aluminum and the copper clad to the lightning. You really need to put more than one ground rod in the ground, by the way. I mean, I would, if you had a tower, I would recommend at least 4 in each corner, and the other thing is I would invest in a good coax switch that has a ground position, because if you're plugging and unplugging, sometimes it's hard to get to that stuff. But if you have a good switch, one of the things you can do with that is set that switch to the ground position. And what it does is it sends all your antennas coaxes to ground. That'd help a lot. And, we think of lightning with our ham radio stuff, but I can tell you a few of the houses here in Nag's Head have poor grounding and have gotten hit by lightning and literally have burst into flames. I pick up a lot of those calls, doing some of the assistance work with the emergency services folks here. And, a lot of these houses, these cottages that are not grounded, they get hit, they go up and they're gone in a matter of minutes. It's amazing. And when I was at social services, they didn't have any grounding in the building, and lightning balls were flying around the lobby. And actually, the secretary left her office, and lightning got into the phone system, and it actually literally exploded her telephone into fragments. If she was in there, it would have killed her. So it's nothing to play with. And, the other thing about putting the coax into a cookie jar, if you get a direct hit, and that coax is in there, what you're doing is creating a hand grenade, basically, because when that lightning hits, it's going to fragment that jar in all directions. And if you're in that room, you got a problem. Anyway, go ahead, Robert.
Yeah, thanks for that, Angelo. You're exactly right, and those are good points. I do need to think about doing more ground rods for sure, and that's what everybody says when they talk about towers. Make sure each leg of that tower at least has a ground rod. That's a good point. Back over to you, Julian, and see where we want to go from here. What do you think?
Yeah, well, let's see. I know there's at least one other person in here besides those of us that have spoken. Anybody sitting here want to ask or say or?
Yeah, Julian, let me add one thing that I
sure. Go ahead, Angela.
When you do those ground rods, it's also a good idea to run a cable between each ground rod so they're connected together.
That's a good point.
Yep. So anybody in the background here listening want to pipe up, say something, ask something? Maybe not. All right. Well, Robert, I think you said you had another related video. Maybe if you can get that handy, maybe we can play that as well and see if that sparks up any additional discussion.
Yeah, it's about the same length as the first one, I believe. It's not quite as good because in terms of being able to follow it, because the guy doesn't do as good a job of describing what he's showing, but it's on lightning arresters and how to use them and how to install them and so forth. But there's enough good information here that I think it's worth playing. So I'll go ahead and screen share and share that one, and then we can see where we go from there.
Sounds good.
You have started screen share.
Hello, Augies Worldwide. I'm Dave Casler, amateur radio call sign KE0OG, here with another episode of Ask Dave. Today's query comes from Robert Brown, KG5BJF. And he has a simple question. He is in the process of buying a house and looking forward to get on the air, and he's going to put up some antennas and so on. The question he has is, how do you determine which lightning arresters are the correct ones to use? Well, Robert, if you look in dcasler.com/reference, you'll see the list of all the materials for the reference station. There is a lightning arrestor in there that is recommended, and that is this one right here. Let's zoom down in on it and see what we can find, okay? We'll try it about there. This right here is an alpha delta, and the UHF connector means PL259. Okay, these are SO239s. And your PL259 connects direct to that. If you happen to be using N connectors on your coax, and you're a rare ham if you do, although some do. There's some who are quite adamant about it. But anyway, most people use PL259. They do have an N connector version. Now, this is made of stainless steel, these parts here. And this connects to your ground rod, and I'll show you how in just a minute. Now, there are two of these available. They're $52 from DX Engineering. Okay. And these are the 200 watt versions. 200 watts means they have a lower voltage at which they'll arc over and protect your equipment. Now, one nice thing about these type, the Alpha Delta, is if you are putting DC through your coax, like to power a receiver preamp or to send something up to a rotator or something like that, these work fine. They have DC connectivity all the way through. Okay, the way they work is there's a little gas-filled arc tube inside, and if the voltage gets too high, that'll arc over, and the voltage across an actual arc isn't very big, so most of the surge gets taken care of here, and it shorts out this side so that it doesn't get to your radio, or whichever side. They're a uniform either side you can use. Now, one thing I want to mention about this is that they don't show, there's a little knob on this side that you unscrew that you can put the arc tube in. The arc tube is self-resetting, but if you get a really strong one, it can burn the thing out, and it's supposed to fail closed, thus protecting your equipment. So if all of a sudden you're getting nothing on the channel, go out and check that plug and see if that's the case. If you run it without the plug, you have no protection. Now, I will mention that in the event of a direct lightning strike, all bets are off, okay? They can do very strange things if you get a direct strike. But these are for very nearby strikes. There's a lot of voltage induced on your antennas, and it can be taken care of here and shunted to ground. Now, this is the one on the recommended station list, which is fine because the ICOM 7300, which is the reference rig, is only a 100-watt rig. So this is the perfect lightning arrestor for it. Now there is a version of this. It's the same part number from the front there, but this says high power, and it's 2,000 watts. So on all of the antennas on which I will use my amplifier, I put these. Now, if you have these, you can take out the 200-watt little gas tube and put in a 2,000-watt gas tube. You can get the gas tube separate from DX Engineering. Okay, I'm just using DX Engineering because they have everything. A lot of people are familiar with them. Okay, so these are the alpha deltas. These are the ones I recommend. However, polyphasers are very popular. Now, polyphaser is a little different. This particular one is 2 kilowatts. VHF 375 watts. It's a DC block. In other words, there's not a straight through DC connection. And the problem with that is, like, if you're using this to protect or receive on the antenna, and you've got some DC on the line that is via a bias T that is powering the antenna, that will not go through here. Okay, similarly, the MFJ mag loop that has the tuner in the shack needs DC connections. That's one of the reasons I prefer the alpha delta over the polyphasers. Okay, polyphasers are also more expensive, but they're also popular, and you can get those too if this is what all your friends use and you don't have any situation where you need to pass DC. You could use the polyphasers too if you want. Okay, now what do you connect them to? Here's one option that could be put on the wall of your house right next to the ground, and one of the connections is to ground, and then the other 3 are for lightning antennas. By ground, I mean about this far away from ground, okay, because you want the wire to come down directly to ground. You can also use this particular device in your shack as your grounding bus. I just use a piece of pipe. You see where it's got the little bend down here with a hole in it? I just hammered down the end of the thing, and twisted it with a pair of pliers, drilled a little hole in each, and have mounted it over there. It didn't cost me a thing because I had the extra piece of pipe sitting around. Another thing you can do is get this type of a situation, which is what I have. I have my lightning arresters mounted directly at the ground rod. Okay, so now this particular piece will hold 4 polyphasers. I believe it will hold 6 of the alpha deltas. Okay, these are polyphasers that are shown on here. And this sits at your ground, and you bring your coax to this. Make sure you go out every so often. These should be waterproofed, but go out every so often and retighten them, because with the normal vibration of just the sound of the wind will cause these to slowly screw off. So you want to tighten them. Now, there's another thing you need to do. This is an example of it. This right here happens to be for my step-by-R control leads. You connect them. This will handle 8 because you just need to connect it and wrap it around it. And it's got a what do they call? These have got surge suppressors on each one. There's 8 surge suppressors inside. This connects to ground. Okay, right here. This connects to ground. Or you can put it at the bottom of a tower or something like that, and it'll protect the control leads for your antenna, rotor, and so on. Okay, now where are these mounted? The actual lightning arresters are mounted outside the house on your station ground rod just before the cable enters the house. Okay, You don't want lightning in the house. You want to keep it outside. You want it by the ground rod. So the lightning, which will follow the path of least resistance, mostly, will come in here and go down to ground. Now these, as I mentioned, are made of stainless steel. Okay, stainless steel with copper, there's a long-term probability of corrosion, but normally stainless steel does not cause very much corrosion. There is some. Stainless steel is designed for like forks and knives and spoons. It's not really meant as a do-all end-all for avoiding corruption. One of the problems is it's not as strong as other brands of steel that might be used, say, for building a ship. What you want to do, because you've got stainless steel, as I showed earlier, you've got the part, that's stainless steel, that is, and that is. Now, you can't tell these away from the galvanized aluminum, the lightly galvanized aluminum that you get. I'm sorry, zinc coated, but I guess that is galvanized. Okay. Stainless steel into stainless steel will tend to what they call gall, G-A-L-L, the gall. They can be hard to get out. Okay, so what you do is you put a lubricant on them, and the lubricant you want is this right here, Jet Lube SS30 pure copper anti-seize. Now obviously it's not pure copper, because if it were pure copper it'd be a solid. That doesn't do you any good. It is a neutral petroleum product that is filled as much as it can be with copper dust. And you put this in on all these parts where you've got aluminum to copper or even aluminum to aluminum. It's an anti-seize compound, so it'll keep it from galling. Plus the copper in there will make sure it keeps a very nice seal. Okay. And this stuff is relatively cheap. This is the quarter pound. You can get a half pound for $30-something. Okay, so there you have it. These are the things I recommend for lightning arresters. There's a guy, let's see if I can find him here. It's Kilowatt Foxtrot, number 7, papa.com, K7FP. They have some boxes that you can actually mount on the wall and then ground, and then all your lightning arresters and everything are inside the box where they're protected from the elements.
All right, back to you, Julian. That's what I got.
All righty, thanks for that. And yeah, very good info there. Very good info. So anybody want to chime in, comment, question?
Well, it's my next job is to cut my feed line at the ground rod and attach it. I've got a lightning arrestor. It's been laying around most of the summer. It's been too hot to get out to do anything, but as soon as it cools off, that will be one of the first orders of business.
Sounds like a good plan. Anybody else? Comments, questions? No one is struck with a sudden desire to speak? All right, I guess not. So I guess that'll wrap up that discussion. Robert, was there any decision about next month's discussion, or is that still kind of to be determined?
Yeah, I haven't heard anything, Julian, Jewel. I haven't heard anything, and so I don't know where that is exactly. I know we there were you and maybe a couple others toss out a couple possible topics, but I don't think anything has moved forward at this point.
All right. Well, And if anybody between now and then has any suggestions on topics, certainly feel free to reach out to any of us. I think we're all good on QRZ. You can send us email if you've got suggestions, or if you catch us on the air, feel free to just throw it out there. Hey, how about this for a topic? We're open to anything. You know, we just come up with stuff because nobody else gives us suggestion, but we are always open to suggestions. We want to make these meetings interesting and informative to as many people. So we are absolutely open to any topic suggestions, and we'll see what we can get it out there. So in the meantime, thank you all for coming, and thank you all who are listening later at home to the podcast. We really appreciate your involvement either way. This has been the CQ Blind Hams Tech Zoom for September 2022. We'll catch you in October.
Don't forget to subscribe to this podcast and visit www.blindhams.com.